introduce our first speaker. And you know, this one, Rainer's tough to introduce because it's like, where do I even begin? And I think we should I think both of our speakers today should be put in the context of Daniel, who presented at the last one. And I think it's like, we have a series of rather remarkable people presenting who are both very, very gifted and deep thinkers in data science application and theory, but also very much operators in the real world, people with business, management, interpersonal skills, people making it in the real world, either as data scientists or as other things. And that's certainly true of Rainer. So the thing about Rainer is I don't know half the time if his day job is data science or not. It sort of doesn't really matter. What I do know is it's very senior. It's what, general manager level at Optus. So that's the main hat he wears. So Rainer moves in very rarefied managerial circles. He's a very capable, effective senior guy. But it's what he does in his spare time that's really amazing. I guess a summary of Rainer, which possibly sells him short, is he's really good at finding really elegant solutions to really complex problems. Where that sells him short is that if I want to find out what the latest interesting theoretical development is in deep learning, you know, things like max out, things like dropout, things like rectifier units, well, Rainer will know all about it and he'll have read the latest paper on it too and he'll send it to me. He'll also have tried it all out in Python, in Theano, or whatever other tools on it, and he'd sort of say, yeah, I've probably done recurrent net as well. In his spare time, he dabbles in trading, and when I say dabbles, I mean succeeds. And when I say dabble, I was having lunch with him recently, and he said, yeah, I was playing with Bitcoin for a while, and sort of, not really interesting anymore. And I said, yeah, how'd you go? Oh, 8,000% profit.
Seven, was only 7,000.
7,000, I'm terribly sorry, I'm exaggerating. See, he wasn't that good. So, a real Renaissance man, a very capable character, and today going to tell us about something, again, completely different that he's been dabbling with, which is voice-activated analytics. How was that for an intro, mate? I think I sold you short.
Thank you, sure.
Come on. Yeah.
Okay, thanks a lot, Eugene. Thanks, everyone. I'm just going to switch now to this other device here and see how we go. Testing. Can everyone hear me? No. Testing. Hello. Might just switch to keep the microphone then. Is that all right? It is on. Yeah. So.
Yeah, I'll play with that one.
All right. Okay. All right.
We tested it repeatedly.
Okay. It's a pleasure to be here, and oh, this is not working anymore. Okay, I'm just going to talk loudly for a while, and we'll see when one of these things starts working. So, very excited to be here and talk to you about, I guess, a different way of interacting with graphs. So I wouldn't call this data science, I wouldn't call this machine learning. This is actually just about visualizing and interacting with your data. So, obviously very important in terms of a data science life cycle. It's working. Testing? Oh, yes. Okay, there we go. All right, so speech-driven graphs. So what I want to cover in this talk today is actually to talk a little bit about a lot of different things and show you basically an end-to-end solution on how you can do this, how to basically use speech with Shiny, with a JavaScript library called annyang and R to actually interact and work with plots. Now, I actually have, just before I get started, I actually have quite a big passion in speech, and I have to make a confession. I'm not actually a programmer or a statistician, that's not my background, that's not where I come from. I'm actually a linguist. I study languages and have a deep passion for languages, and so I actually came across speech recognition and neural networks back in my uni days. So I often think, well, why does it have to be so difficult? Why do we have to learn these technical languages to actually get anything interesting out of data? And so I have an affinity in general to easy ways to access things and easy ways to do things, and I think speech is one of the more natural ways to actually interact with any system. So what I want to cover, I'll give a bit of an intro to who I am, talk a bit about speech systems in general, then I'll show you both the inspiration, where I started in terms of getting this idea of working with R, Shiny and annyang. I'll talk through then the whole system in terms of how I've set it up, which I'll also happily share with all of you. What I'd like you all to think about while looking at this is to challenge you to think not about the specific example I'm going to show, but how you could apply the same principles to your own meaningful problem. Maybe you want to extend something like this, maybe you want to do something totally different, but I challenge you and encourage you all to think about that. And then we'll give a demo as well. Now I'm not sure how this voice thing, I have to talk to my computer, is going to work with a microphone, and hopefully the internet connection stays stable. So we'll see how that goes. So a bit about myself. I'm a chief data scientist at Blue Guava Predictive Analytics, which is my own business, and basically doing research and development into deep learning, natural language processing and financial markets with primarily Python and R. I've worked across business, IT and analytics projects across various industries, across various countries. Personally, I really love probability. I think it makes the world go around. You probably won't see that here, but it's crucially important even to speech and finance. And cloud computing, application over theory. So I like making things work end to end, even if I'm hacking it together. And open source. So a bit about speech recognition. Just a definition, which is quite simply the ability to recognize and translate spoken language into text. The characteristics of this are, traditionally it's been a very complex problem to try to solve. People have been trying to do this and done it to various levels of success for decades. The sorts of challenges you get is basically differences in speakers by their accent, pronunciation, pitch, volume, speed. And it's also very difficult to achieve human level accuracy when trying to transcribe from speech. Why has this been a challenge? Well, you have things like background noise, acoustics, multiple speakers, environmental things. And again, you'd be quite familiar with some of the old, traditional speech transcription systems, which requires a bit of training that you have to do to make sure it can learn the speaker and how the speaker's speaking style in order to get the best from it. That is as opposed to then an independent solution, independent of the speaker. Then what we have is levels of difficulty. You can have discrete words, so almost like hard-coded, say a word, it does a command. You have connected words, where you're saying a few words together with a clear articulation. That's a little bit harder to do. And then you have what a lot of the big players are doing these days, which is continuous natural speech with large vocabulary. And that is extremely difficult and has not been mastered. So why is speech much more interesting now than it has in the past? Well, there's actually a lot of developments which have happened probably only in the last 5 to 6 years, and that's been enabled by deep learning, which is really has had a sort of a big uptake since probably about 2005, 2006, when Jeff Hinton basically published a paper saying basically with a much faster way to do this particular use this particular method of machine learning. And companies like Google, Baidu, Microsoft, IBM, and Nuance are the ones that have really gotten on the bandwagon here, and speech recognition has just improved phenomenally in the last few years. So what I'm actually going to show you is just a free API that's available now. It's not a production-ready speech system, and it's really quite impressive considering you don't pay for it. Then the latest sort of developments actually, best in class is deep recurrent long short-term memory neural networks with character level embedding. And what this actually is it's adding little tricks into how speech gets processed. So you actually start using things like context and learning context, learning when to forget a context, and character level embedding is actually allowing an algorithm to not even understand what language is or what words mean, but just how characters next to other characters can then come back together and actually create whole words and whole sentences. It's really quite impressive. And typically phonemes have been, they're basically the smallest sound that one can make in a language. So it's a bit like syllables, but it's like if I said father, you actually have f, a, v, e. Traditionally, people have tried to represent speech as we would understand it, i.e. into phonemes. And actually Andrew Ng from Baidu, he actually went, no, that's too complicated, it's not even natural enough, I'm just going to pop it into this deep recurrent neural net and see what it does. And they've been getting their results with this character level embedding, totally ignoring how all the linguists said you should do it. So my motivation, basically I was having a coffee one Saturday morning, just wandering around, and I just happened to be struck by the question, why do business people, why do marketing and sales people have to care about things like Excel and SQL and Python and R and Hadoop and Tableau when all they want to do is ask pretty simple questions of their data? Why do they have to tell some technical person how to make a view that just gives them their latest sales figures? Someone has to pre-build, predefine all of this stuff for them. When really, business people care about business and doing what is important for their jobs, not about report building, programming languages, scripts or algorithms, as much as we would like them to maybe care. So what I'm going to show you is my use case where I am basically taking, I want to see visualizations of stock prices using the R library chart series, interact with these visualizations with my voice, see some new visualizations that give me what I want after I've spoken. And that's using Shiny. So the inspiration is, when I was thinking about this problem, I thought, well, how can I do this without learning a technical language or learning what sort of things I need to do? Then I thought, well, speech is a fairly natural sort of interface, and Shiny is a pretty good sort of tool. I'm not sure how familiar you all are with Shiny. Maybe could I just see hands up, how many of you have actually used Shiny? Okay, good. And how many of you know what Shiny is? Good. So I will, just for the few of you who aren't maybe familiar with it, I'll give a bit of an overview into Shiny a bit later in the talk. But what it's really good at doing is allowing you to provide inputs to your graph, so selecting different variables or things that you want to change, and then updating the graph pretty much as you make the changes. It's interactive. And so I thought, well, Shiny's pretty good, speech is pretty good. I'll just have a look if anyone's done this. And so I'll just, I might just go here and see if we can have a look at this example from a guy called Yihui Xie. Just to give you an idea of then what I was looking at and what I decided to work from. Okay, title, this is really awesome. Title, this is really awesome. And there we have now modified the title. Let's try something else. Let's add regression. Regression. Bigger. So I thought, wow, that's pretty cool. I can talk to it and it does stuff. I can work with this. So I took that, thought it was fantastic, and then tried to take it apart and see how it was working. So we start with RStudio, which is, if any of you are working with R, or aren't working with R, you should definitely be using RStudio. It's a fantastic IDE. Shiny, which is an interactive visualization library in R. Annyang, which is a speech recognition JavaScript library wrapped around Google's Web Speech API. A Chrome browser, because it needs to support this API, not all browsers do. a microphone, which is also useful for karaoke and is found on most devices. And we also need a stable internet connection. So the limitations of this is that basically, as you could see, it was almost one word, it was one action. And we can only perform one action at a time. The overall state was sometimes saved, but you saw it change things sometimes there. And actually, I didn't give the example with color, but you'd see if I said color, it would have spelt it differently, and therefore it wouldn't have matched the command, therefore it wouldn't work. So localization's not for us, it's for Americans. Typical. So what I thought, okay, how do I want to modify or improve this? What I'm going to do, I want to have more than one command actually working every time I say something, not just one. I want to be able to do it for any financial time series, not a fixed data set. I want, for my natural language processing, I want to just pull a regular expression from a string rather than have this hard-coded to a command. And again, you can use much more. You can, hello, testing. I've lost it again. Hello? Okay, so, hello?
Oh, does not, do you know? No, not again.
Okay, I'll just talk loudly again. Natural language processing, you can actually use much more sophisticated and fancy natural language processing. For simplicity's sake, for this example, it's just regular expressions. And for visualization, rather than the default plot function, I want to use chart series, which is an extremely good R library for representing financial data. And then for state, I wanted to update the current graph and retain my state, so I can add layers on rather than having it reset. And then if I want to reset, because it's a bit busy, I can just ask for it to reset. So the system, basically we've got me talking, then annyang does the talking to text. Our Shiny app does a lot of the smarts, which is pre-processing, cleaning up our text, matching a set of conditions which are predefined, pulling out features from those conditions, defining our plot, and then saving our settings. Then our browser just presents the updated plot. In terms of the structure, in terms of what my files look like, we've got a JavaScript file which defines our speech commands and what goes passed to Shiny. We have the app.r file, which contains our Shiny app, which is comprised of a UI and a server part. That's going to be on YouTube, folks.
Well, I breathed it. Fellow partner, the trick was switch it on and off again.
Oh yeah, that old chestnut.
I hope it doesn't understand that.
Yeah, it goes nuts. Then we've got two config files, one which just holds some default settings whenever we reset. And we've got our saved state, which is saved as a different file. It's a different set of parameters. Just for this example, I've got 4 different stocks. You could have as many as you want. You could actually download, you can execute any commands you want. It doesn't even need to be plotted. In this example, I've just got these 4 for speed's sake, and that's your typical stock data: date, open, high, low, close, volume, and using the adjusted versions, which you should always use if you're doing anything with financial data. And then we're referencing this annyang JavaScript script from within the Shiny app UI. Okay, now if we look at the JavaScript file, the other one looked much more complicated. This is all I'm doing, which is basically whenever I say now and a string after that, whatever I say after the now will be turned to text. It'll go away to the web speech API and be returned as text. Then it will be passed to the Shiny server using this shiny.onInputChange function, and it will pass whatever I said through as text. Then our R code is basically just, we're loading libraries, string R for string manipulation, TM for text mining to do our natural language processing, quantmod, which is for our chart series visualization, data.table to load our data faster, XTS, which is fantastic for time series, and TTR for our technical indicators. Then we just are setting our working directory. I have just one function, which is to import the stocks. Not sure if you're interested in looking at that. That's not the interesting part. And then in terms of what we are doing with our Shiny app, now that we've got our text there, we've got two parts. One is the UI, how it looks, and there we define what we see in the browser, any HTML, JavaScript changes we want to make, and the graph, what our plot is. Second part is our server and all the logic, so the fact that it recomputes when we speak, text processing, data manipulation, the features we want. Then the UI, I've actually, traditionally you actually have two separate files to handle this UI and server. I've just got it in the one. And what really in the UI we can define, you might see their height and width. We can say how much of the screen we want our plot to take up, and we want to define what is our output, which is the plot output function here. And then we'll refer to the plot variable later in our server code. Shiny App Server, all we're actually doing is loading our config file, which has our default parameters. We're then receiving our input text from this reactive function, and then our output plot is just the plot that we're going to be rendering. Now, the reactive function is something that's quite a specific and special little feature of Shiny, and this basically recalculates whenever the value changes. So in the case of speech, whenever we speak, whatever is our input text changes, and therefore everything else recomputes, and that's how we get the updated graph. And now let's have a look. Hopefully it works. Okay, that's not quite fitting on the screen, is it? No. How can I get that to fit? Sorry, that's a bit of a... let's just do this. I'll move it around so you can see. Okay, now add an exponential moving average. Now add an exponential moving average. There we go. And what are we looking at here? Well, we can see there's a trend, and we're looking at Google stock, by the way. So I'm not that interested in Google. Now show me Apple. Now show me Apple. Okay, that's all right, but you can see the data from 1980 to 2015, but we pretty much can't see what happened up to 2004 because of the scale is too small. The movements are too small. So now show me log scale. Now turn log scale on. Now turn log scale on. It's not actually working on the internet. Now turn log scale on. Now reset. Okay, now it's starting. Okay, so that actually is log. Is that log scale or Google? No, reset. Now show me Apple with log scale on. That's better. There we go. So now that looks completely different because we can see log scale. Now show me Baidu between, actually from 1992 to 1996 with an RSI indicator. Okay, got the dates wrong. Okay, now show me from 1992 to actually it doesn't even go that far. I was looking at dates that don't exist. Now show me from 2007 to 2009. Now show me from 2007 to 2009. because that's a bit more interesting. 2007 to 2009, and we saw that big dip there. Oh dear. Okay, now just show me the last 5 months with a parabolic SAR indicator. Now show me the last 9 months with a parabolic SAR. Okay, last 9 months, there we go. Yeah, very nice. Now show me a line graph of the last 30 days. So you can see we can sort of play around with a few different features here. Now, I'm not sure how much I've got talking-wise. Am I going for time, Fabian? I can... Questions? I can actually... No, I was just suggesting, if people are interested, I can show you through some of the R code, or maybe we can even do that later. I can share it with you. I'm happy to share this with you anyway. The R code's fairly straightforward, but I've probably run out of time. So.
Questions are fine.
Questions? Okay, great.
Sure, people have questions.
Yes?
Could you go into a bit more detail about once you've parsed the speech and turned it into text,
Yes.
how you then turn that into plotting commands?
Yeah, sure. So this is the bit that I thought might be useful. I'll actually go to R and oops. So actually what we're doing, I'm actually just getting some raw text. So coming in here, I'm actually just pre-processing that string, taking out stop words, so all the most common words in the English language. Then all I'm doing is actually some regular expressions to look for words that appear there, or bits of words. And so whenever I see different bits of words here, that'll actually populate one of these features. Now, I have a bunch of these looking for different commands, so different types of things we can do. And then what I have is a set of if-else rules, which basically say if I find this feature, then do this. Or, if we don't find it, just get the last version of that from our parameters. And then we just do that for all the different functions that we're doing, and then right at the end, we have a whole set of possible technical indicators, and we are literally just creating a plot. So all the plot is just actually these 4 lines here, but it's taking in all the inputs that we've calculated in features. Yeah. Any other questions?
Let me just. Can you actually share that with code?
Yeah, I will share the code. So I'll put it up. Haven't decided where I'll put it up. I'll put it up somewhere like GitHub, and then you can. I'll put it up on the meetup. I'll show you how to get it.
There's one more question. Last question.
Yes.
Sorry. So, is that possible if, for example, when your program is running, and if I say something like SAR, the program will just pop up the charts?
Yes.
So does that mean you use? So, for example, you like click the button, so then the program starts receiving the voice, or
You can absolutely do that. So. You can define basically when you want annyang to start or not. So as long as you've got something that's in the JavaScript as to how you want to do it. You can also you can set a timeout as well for when you want it to stop listening for stuff too. So there's a few different things you can do. This is just the most basic like default settings you can get. Yeah.
Are the limitations?
No, you have to wait for me though.
What are the limitations there? Are they in the conversion of speech to the raw text, or from the raw text to a command?
Depends on where you're looking. So there's so limitations. You've probably got the speech to text is pretty good actually. If you look at it, yeah, it messes some stuff up, but it's not that bad. And actually, it's more in the domain-specific language or the context-specific language that you're defining around your commands. Like, what do you want it to look for, and then what do you want it to execute? So some of mine were just hard-coded things. This equals that. Others, I can put in different parameters. Like, I can say the last 9 months, quarters, years, and it'll work out what goes where, and that's just again through regular expressions here. So yeah, you have to define this so then your users know this is what the possible things I can do are. Yeah. And just quickly, actually, just some limitations and improvements on this. ggplot, another great charting package in R, something I would like to extend or encourage you to look at. Chart series is not that great with Shiny. It's really good by itself, but you can update a lot more things when you're just using chart series standalone. But actually with the Shiny, it only does one update, so it sort of limits you a little bit. Haven't saved the state of all parameters in this, and you can actually extend this model however you want. And there's a few bugs with the subsetting data just in case you download the code and want to try your own thing. Just in this example.
Okay. Please join me in thanking Rainer for a terrific presentation.
Thanks, Eugene. Thanks, everyone. Yeah, look, 10th House, been a big supporter of data science for a long time, and I was very happy to start, as I said last time, start paying back and pizzas and everything for everyone. But look, 10th House, I'm the analytics lead at 10th House, very much all focused around analytics, BI, and digital, and where they all sort of come together. Basically, here is a resource for the data science community. If I can be of any help, answer any questions about recruitment. Recruitment is quite a hot topic now around the data science community. If anyone's got any questions, more than happy to answer. Or if anyone's looking to build their teams, please come and talk to me. There's some very good individuals out in the marketplace at the moment. Please have a look. I meant to have our website up, but it's 10thhouse.com.au. Have a look at the jobs on there. And please, if there's any questions with regard to that, please come back to me.